So let's be very clear on what we talk about, what we mean by fairness. First of all, it's not fairness, it's fairness of ordering, fairness of timestamps, fairness of access. This is what we're talking about, 3 specific kinds of fairness. And what do we mean by that? So here's the idea. You do a transaction, it goes out to everybody, and we really want to know what the timestamp is on it. Maybe we're going to put them in order, and we really want to know what order they're in because we're doing an auction, and it matters what order you're in. So what we should do is we as a community, our consensus algorithm, should put a timestamp on this transaction that is the true time that the transaction reached the community. Wait, the community is not a computer, it's a bunch of computers. At what time did it reach a bunch of computers? That's not one time, it's a bunch of times. I could ask each person in the community, when did you receive it? And I'll get a whole list of times. Oh, well, you know what we can do is we can just say, when did you first reach most of the community? In other words, take that list of times of when each person received it, sort them in order, and take the middle one. That's a reasonable definition of what it means to be the true time at which a transaction reached the community. We don't want to penalize you if there was one straggler that didn't get it for a long time. And we don't want to reward you for just one computer that happened to get it. We'll do it when you reach the majority of the community. And in our gossip protocol, you're going to rapidly reach every single person right after that. So that's a reasonable definition of the right time, the true time. Now, what is that going to be? We take the time when you reach everybody, we put them in a list, sort them in order. What you're going to find is there's a whole bunch of times in the middle that are all about the same, and then there's some outliers, a few that are much later and a few that are much earlier. That's typically what you see, a bell-shaped curve with a bunch of times in the middle that are all about the same. We're taking the middle one. But what if an attacker wants to change this, not change it, but influence it to be not the truth? What if an attacker, one of our nodes is malicious and wants us to have a consensus timestamp that is far from the true timestamp that it ought to be? Well, they really can't. They could say, I received this in the year 37 billion. Okay, so that's one more time at the top of the list. And when I take the middle of the list, maybe I've gone down by half a notch, and all those times in the middle were about the same, so they really haven't had much influence. Or maybe they said, I received it while dinosaurs were roaming the earth. Okay, well, now you've moved me half a slot down this way. But still, there's that big clump of numbers in the middle. They're the same, and I picked one. In other words, it is very hard for attackers to drag the time very far from the true time of what it ought to be. And that's what fairness is. If we have 100 computers, each of them has 1% of the vote in some sense. And it's not possible for one malicious computer or a small group of malicious computers to drag you too far from what the truth is. In fact, as long as the majority of those times are honest, the middle one will be honest or will be right between two honest ones. Guaranteed. So this is fairness of timestamps. Sometimes that matters. The timestamp matters. You have a legal contract that says, do this by noon on Tuesday. So now you have a fair timestamp from the community saying, yes, you did it 1 minute before noon on Tuesday. You succeeded. And now, because of the state proofs, you can know for sure that they've agreed. And not just you, you can prove to a court that you did it before noon on Tuesday. You can prove to somebody else that you did it before noon on Tuesday. We could prove to another shard if we cared about that. All those things. That's the timestamps. More often, more important is the ordering. Do we have fair ordering? For an auction, you care who bid first if two people bid the same amount. For a game, you care if you shoot me and I dodge. Which one happened first? Did you shoot before I dodged? You get a point. Or did I dodge first? You don't get a point. So often, the ordering matters. But what we're going to do is say that the official order is, well, whatever order the official timestamps are in. Our consensus order is the order of our consensus timestamps. And so if it's hard for an attacker to drag the consensus timestamp too far from what it should be, then it's hard for them to have more influence than they should on the order. So we have fair ordering. We also have fair access, which is just a way of saying these systems are very resilient. What if you call up a node and give it your message? I mean, you're a node. You call another node and try to pass the message on to it, and it's malicious and doesn't pass on your message. Well, who cares? I'm calling 10 nodes a second. Most of them are honest. I will very quickly find a node that's honest and give my message to an honest node, and it'll pass it on. Not a big deal. Or maybe I'm calling multiple nodes at the same time. And if one of them is dishonest and doesn't pass it on, who cares? I was calling other nodes at the same time. Your messages spread out very fast. It becomes very difficult for one malicious node to stop your message from spreading to the community. And if you are a client, you can call up a node and very quickly know whether or not they did it, and they can't lie to you. State proofs, again, give you fair access in this sense. They can't pretend that they gave out the message when they didn't. And they can tell you whether consensus was reached or not, and they can't lie. And if they're malicious and they don't do anything, after a few seconds you say, well, forget you, I'll try somebody else. And if you really want to hedge your bets, you can talk to several nodes at once. This is fair access. So fair timestamps and fair orderings is sort of this math proof that it's fair because of various math things, and fair access is just inherent in the nature of this gossip protocol, along with the fact that we have state proofs, which makes things nice, because the node can't lie to you. So this is fairness.